Find current through 2 ohm resistor using Millman's theorem. Okay, in the given problem, observe carefully. So we know that in Millman's theorem, we can apply Millman's theorem only if three practical three voltage sources are connected, or three or four. Okay, connected in parallel, we can convert it into single voltage source. So here actually uh, two are there in parallel. So but this one is one more extra is given. So here please remember, here any resistance in connected parallel to the voltage source can be ignored. This is redundant. This is redundant. So we can remove this. Okay. Any resistance parallel to the ideal voltage source. Suppose any resistance is here, then we cannot ignore. It is connected to with parallel with ideal voltage source, because in parallel voltage remains same. So across 2 ohms also 5 volts will be there. So it can set as a voltage source of 5 volts here only. So we can ignore and we can remove it from the circuit. So remember, any resistance with ideal current source is any resistance in series with ideal current source can be ignored. Any resistance parallel to the ideal voltage source can be ignored or redundant. So this 2 ohm is removed. Okay. So this circuit is reduced to this. So now I can apply Millman's theorem for these three parallel voltage source. Please remember, voltage source plus is minus here, minus plus is plus, minus is here. So now you have to apply um, uh, Millman's theorem. So what is this is a DC network only. So instead of impedance, let me call it as you can write in terms of resistance only. So the current is given by is E1 by R1 plus E2 by R2 plus E3 by R3. If I convert into currents, this will be there and divided by 1 over R1 plus 1 over R2 plus 1 over R3. And let me take the calculator, and please see here, if I convert this one to current source, the current goes upwards. If I convert this one to the plus side arrow mark, if I convert this one to a current source, this current will go from minus to plus. So this you have to subtract, and this will go upwards. Between this and this nodes, two currents are going upwards. This current is going downwards. So you have to subtract this. This you have to write minus. Second current you have to write minus. So I am changing now. This is general formula by considering all plus at the top. Now for this particular problem, this is minus. For this particular problem, this is minus. Now let me calculate using this is minus. No, I don't know. This is minus. This particular problem, this is minus because it is coming down. This current is coming down now. So that's why it is minus only for this problem. See the polarity of batteries. If all are plus 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 at the top, then all are positive. If any above negative is there, that you have to pay negative. Suppose this is negative at the top, then this also you have to subtract. Now using calculator, let me calculate what is the value of E. Okay, we should get 26 volts. Let me check whether we are getting same answer or not. So first, what is the steps? It should go to this E1 by R1, 50 by R1, 5 ohms. It is 5 inverse. If I is there, you have to write within a bracket and inverse. Here there is no I term, so 50 into 5 inverse minus E2. E2 is 20. Minus 20 is there, no? That's why. Minus first. So minus 20. Here plus is 50. Here minus 20 into 2 inverse 20 inverse 20 inverse. Now for this 16 into 4 inverse divided by 5 inverse plus, it is 1 by R1. 1 by R2 means 20 inverse. Yes, R3. 4 inverse. We are getting 26 correct answer. Next we have to calculate what is this. This is equal to, okay, I will write those are not taken. 50 by 5. For this one I'm writing 50 by 20, 20 by 20 plus 16 by 4 divided by 1 by 5 plus 1 by 20 plus 1 by 4, it is equal to 26 volts. So this is equivalent voltage. Now what is the value of Z, or what is the equivalent of R? R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. It is equal to numerator part, we have to make 1 as that's all. This whole numerator you have to make 1. We calculated this portion. We calculated this portion by this, no? It is going to get 2 ohms. Okay. 1 by numerator 1 by 1 by R1. 1 by 5 is 5 inverse. 20 inverse plus 4 inverse. So you'll get 2 ohms. So this is here 1 divided by 5 inverse plus 20 inverse plus 4 inverse, which is same as this. 5 inverse means 1 by 5. 20 inverse means 1 by 20. 4 inverse means 1 by 4. So, and reciprocal of that, that is 1 divided by reciprocal of these 3. So, you'll get 2 ohms. So, your answer is correct. We got 26 and R is 2 ohms. This is 2 ohms. This is 26 ohm. And what is RL? Find current through RL is equal to 2 ohms. This is your RL. So, connect RL of this. Then current is given by voltage value, or you can write E also. If you are getting confusion, write E here. E divided by, okay, R plus RL. So 26 by 4. Okay, 26 by 4. You can calculate 26 by 4, 2 plus 2 is 6.5 amps. It is 6.5 amps. So IL is equal to 6.6. You can see here down. You can write amps. So this is the answer. So you can easily find out, and you can easily get minimum 8 to 10 marks in the Millman's theorem. Anyway, 2 questions will be there. Okay, in the exam, if you prepare, give first option for Millman's theorem problem. If you properly practice these 5 problems or 6 problems, same type problems will be there, and you're going to make a mistake only in this part. You're going to forget, you're going to take reciprocal of this. Many students will write 1 by R1 plus 1 by R2 plus 1 by R3 as here. For this R, many students, they will write 1 by R1 plus 1 by R2, 1 by R3, and you take reciprocal of that. So that's why don't make any mistake in finding this R. Okay, easily you can get 8 marks. Thank you.